between what is a cryptocurrency. Somebody put it here. Let me check whether you were able to understand the concept. Please type it in the chat box that what is a cryptocurrency. Or if you are aware of any cryptocurrency, please put it in the group. So that let us know whether you have an understand the concepts of cryptocurrency or the blockchain concept. Some terminologies what you have so far we have discussed. Please put it in the box. I need an input from the participant. It should be a very interactive. Hello. Somebody put it in the chat box so that I need any feedback from your side. Digital currency, digital tokens, yeah. So it could be anything. So digital currency or the virtual currency. So see here, one of the blockchain application for the financial transaction is one is the cryptocurrency and one is the Ethereum. Now let us move on to the. I told you in the blockchain, it is a bundle of 3 or 4 concepts. One is database, which are in a distributed manner. Another is the data structure in order to access the data, which is stored in a particular system, in a file system or anything. So data structure is required. I have already told you Merkle tree is one of the things. So Merkle tree Patricia is there. These are the different data structure which been applied in the blockchain. So you can, whenever you are free, you can check out what you mean by Merkle tree, how the Merkle tree data structure will help you in the blockchain, and Merkle tree Patricia is there. So there are different concepts are there. So then we have a cryptography part, symmetric, asymmetric cryptography is there. Nowadays, world is revolutionizing towards AI and ML along with the quantum. So we are coming with a quantum cryptography called QKD, and post quantum cryptography is coming. A lot of research are happening. So the world is going very faster than we are expected. From 5G to 6G, it could be any other generation communication network. So earlier we had 100 Mbps. Now we can go beyond 1000 Mbps or 10,000 Mbps are there. The terabyte transaction can happen over an optical fiber, anything. So that's why technology is being improved every day to day. See, as per the total research, so every 15 days there will be a new concepts. Every new technology is being implemented with a modified version or updated versions are there. Now let us take up the blockchain. Blockchain is also coming with new things. Many people are doing research on how the quantum enabled system, quantum computing or quantum cryptography, for example, random number generation as a cryptography part. How can the quantum cryptography using the random number generation can be taken into the consideration for the validation? So a lot of research are happening. So now let us take the basics as we are discussing with the basics. So distinct between the database and the blockchain ledger, we have to think about it. So it begins with certain architecture. So I have told you now what is the difference between a centralized system, distributed and decentralized systems. So in a network system, which is there in a centralized, distributed and any other decentralized system that you have to think about. Usually any communication will happen between the client and server. So we'll call them as the master slave client server architecture or network architecture, distributed architecture, parallel computing, distributed computing. Anyway, we all call them the network when you have to the things. But in order to store that one, we have to store the data in those environment also. Nowadays, database earlier we had only the client server, then we moved towards the cloud. Now from the cloud we are going to data centers. From data center, the future will be, we don't know like how it's going to impact the storing of data. The future will be like your mobile devices can work with the edge computing and fog computing. So any devices can be done, and your future IoT are enabled is there. So IoT 4.0, industrial version 5.0, robotics, IoT, everything are integrated over there. But as of now, but everything we need a data. So we have to distinguish between the databases and the blockchain ledger. So let us between the things, what the database contain. For example, if you are a student, what is your database there? Your admission data, your academic credential data, then your when you got out of the course, you'll be having certain credential data there that is being securely stored. But how the, if for example, how to validate your credential through third party? Because I am other person wanted to recruit you, so recruiting agency wanted to see the credential of your degree certificate. How we are going to do? So, as example, we have a concept called a digital environment, so that your technology being embedded with a blockchain technology, all your academic credential, so can be put into the integrated with your marks card with a proper embedding system, which can be verified with certain links. So that is called the proof of work or a proof of stake that we can call them. So in order to validate your credential of the your degree certificate or master, so using that one, so that proof of work or proof of stake, the validity of the certificate that can be integrated with blockchain concepts where my database are stored things. So that's why distinct between the normal database to the blockchain ledger. Sometime in the normal database verification, we request lot of queries has to be done. It is taking long time to process the data. For example, if you know the database concept, in order to validate, I have to do the join operations. I have to take up the three or more multiple entities or the multiple tables I have to take and retrieve the data. So then only you can do that. But when you have that something like blockchain ledger, so parallelly, I can validate those things, and it is digitally identified. All the updates are available, and even master copy is updated instantly. You need not to worry about those things. So there are some storage architecture and the execution architecture of the database is stored in the normal database to the distributed database in the blockchain is are more relevant to the technology. So now, if you take the blockchain, I am giving a comparison over here. A regular database has the admin and centralized control are there. So it is will be validated by the centralized authority and centralized control is there. So any entity with the rights can access the database because so you people I think might have heard about that entity level access control, attribute level access control, role based access control, and in tuple based access control. So there are various access control on the database is there, and only entities entitled to read or write permission will be there. Sometimes you need to, you can you have the ability to read it, no update. For example, I will tell you, when you go to the bank, you are deposit your instrument, that is your check or DD, your deposit into the teller in the counter. So he will validate the your the instrument, that is your DD, check or withdrawal slip. Just you want to read that data and you want to validate. That's all. You can't change anything. Only thing is, it will be authenticated by the manager based on your instrument. They are going to check your authentication with your photo, signature, or any other digital signature. Whether genuine instrument is that like bank check or the DD what has been given or a withdrawal slip that you have given taken through the bank. It is validated or according to the proof things. So you will going to validate that, then you will be entitled to redo that options are there. That is all manual things. And database are fast, but because you can, for example, if you do the transaction database, regular database, you can do thousands of transaction in a particular time. So no history of records, ownership of the digital records are there. That is a disadvantage. You can't have the digital ownership of the particular digital record which has been created. The transaction ownership is be only thing is few related like time stamping and that can be done, but digital ownership is not available in the regular databases. Now come to the blockchain based distributed databases, which is called the decentralized distributed ledger DLT. So in the distributed ledger concept, so there will be a no one is the admin or in charge. So anyone can access the public in a blockchain, and so and anyone with the right proof of work can write onto the blockchain. A blockchain are slow because we have integrated two things here. One is the cryptographically encryption is there. You have to solve the the cryptographic problem, that is through authentication method, proper authentication, that you should to show the proof of ownership, proof of work should be there, authenticated should be there, history of the records and ownership of the digital transaction records are available. For example, I will tell you what is the digital ownership of the records. For example, you have a property, or you sell it to somebody else. Assume that you have assume that you wanted to buy an apartment or a villa or a plot. Assume that if you take in real estate business model, in the real estate business model, there will be land will be there. The owner will sell to the builder or a promoter or a financer or the bank. They will sell the land. So one thing is the authentication, the ownership of the landowner is now distributed to all the people who are the builder, who are the promoter of the particular property, who are investing on the property development, and other advertisement agencies or any other agencies. It could be an online platform. They all become the stakeholder of the thing. So, in order to validate the ownership of the land record, I'm telling you. So, if it is if a real estate scenario, so ownership is validated. Now, when you have a contract between a landowner to the developer, there is an agreement, digital agreement will be there. This is how, what time, how you are going to develop the your land, what is the proposed, what is a commercial or an residential area, or it could be an industry related development or infrastructure development like highway authority or transportation, anything that could be anything. So the agreement to contract will be there in the blockchain, that is highly secure transaction will be there. The agreement are recorded properly, so that while whenever the ownership is there, again the financer want to invest on your project also, it could be a bank or investors, angel investors or anything. So those investor database also been recorded with this, integrating with the blockchain ecosystem with the framework. So then come with the again the wanted to purchase buy the real estate property from outside. So I wanted to buy a plot or a villa or anything. So I'll claim that. So now I will pay my part payment to the developer or a who are wanted to doing this project. So that again the ownership as a partial ownership of the purchase are also there. So these are all called the data. When you take up in the regular database, everything are individual entity, and we have to integrate it in order to summarize the data. But in the blockchain, everything is are visible. Everybody can access the data. So all the assets, ownership, and digital records are being integrated in this blockchain concepts. Hope you understand. I need any feedback for this one. Hope you understand the concepts, what I am telling, what is the how the our regular distributed system, decentralized systems are different. Database, how the centralized data systems, database is different from the decentralized database system. How the transactions are validated with a regular blockchain database to the blockchain ledger concept called distributed ledger concept. Somebody please post it in the group. So that is, I want to know that whether you are able to follow up. Okay. Hope you people understand. So we have the concept called cryptography part, hash function and digital signature. Cryptography is there. Encryption, decryption of the there two main cryptography concepts called hashing and digital signature is there. So they're all part of the cryptography. How the hashing can be done, how the digital signature can be done, we'll go to that one. There are three forms of encryption that are widely used. Symmetric cryptography, they use the same password or encrypt to decrypt. That is called two-way functions. So another one is asymmetric cryptography, one password to encrypt, or another one password to other password to decrypt the things. That is called the password come by pair thing. Hashing means map to the fixed size. So one-way function. For example, I have a transaction ID. I wanted to hash on the my transaction ID with certain hashing function. Hashing function could be any algorithm. So random input number. For example, my hash value, the previous hash have the value around 64 bits. Now I wanted to make it the regular standard as output with a fixed string or a fixed size. So I use the hashing function. So that is my all the transaction information with the time stamping, all those things that can be converted into a fixed side of value. So that is called the one-way function. Why it is one-way function means you can't go back to the initial one. That means once you hash the value, the original value will not be known to you. You can't identify the original value. That is the importance. That's why it's called the one-way function, not the two-way function. That means you can't do re-engineering or the reverse engineering to get back the original value. Because in order to secure the transaction, the hashing makes very much technically feasible in order to validate the hash function. So hash function is the algorithm you can apply in order to do the hashing of the value, mapping a random input to a fixed size of output. So that is the hashing value. So if you take an hash means, assume that I am giving a word, a string called hello. I am going to use it with the hash function, with the hashing technique. I'll be getting output like that. Some random number will be getting. So I'm telling no, any input with a fixed standard output I can get it. So in the symmetric encryption, I am going to send a string called hello. I am encrypting with the one common key. So decrypt with the same key. So we'll get back the original string send or original text send. So that is called the encryption. So encrypted data has been corrected to decrypted, and we'll get the original version. So now I am using the asymmetric encryption. Hello, I am taking in asymmetric means so two different keys are using. One is the public key, another one is the private key, and output you will be getting things. But these public key and private key should be shared between the two users. That means I am going to use a public key, but you have to use the private key in order to decrypt the data. That should be shared among these two people. So that is the you will access the private key of the party two, and party one or the sender will have the public key and you will encrypt, and the receiver have to decrypt with the private key, which is entirely different between the public key to the thing. So that is we can have the two different keys the things. So hash is, for example, I am taking the different techniques and I can use the different hash function as a mathematical possibility. Now see, assume that I am sending a value called 2345. I am using an hashing algorithm or hashing function. So modulus of any value. So modulus of 15, I am getting a value as output. So that is by using the 5, I can't go back to the original value 2345 because it is an one-way function. We can't go back to the other function. But whereas the symmetric key encryption and asymmetric encryption, we can get back the original number by using either private key or a public key. So, or both combination, we can get the value. That is the way the hash is more secured. Hash function, we can use it. So, hash function is some algorithm that use and which is a part of the mathematical calculation use it, like any other combination of the mathematical combination that you can do it and you can have it. So description is that if you take an cryptography, so I can use the different hash called SHA-256, RSA algorithm is there, SHA algorithm is there, SHA-1 is there, SHA-4 is there. So many algorithms that you can use it. So hello value, that string value being hashed, and you will be getting a fixed value with using that I can get back the original value. But using the symmetric encryption called AES algorithm 128, this is 120 is the bit. So 256 or 256 bit will be there. That means your hash value have the 256 bit information. There it is encoded in a 256 bit information. Now symmetric encryption have the AES algorithm called 128. Your key has been encrypted with a 128 bit value. So when you decrypt or encrypt, you will get the value. Similarly, asymmetric key also, they use the RSA 1024 bit encryption algorithm there. So your encryption will happen with 124 bit probabilic values. So when you decrypt it, you will get the thing. So we have the another asymmetric key encryption called SecP 256K1 is there. There are different algorithms are there that you can validate the transactions. So there are again we can have the different hash code and also can be done, and we have certain consensus protocols are there. So that is called the Byzantine fault tolerance. Is that Byzantine fault tolerance was not the new one. It was there since the computer concepts and mathematical functions are there. Earlier, the Byzantine fault tolerance was used for the defense purpose, for the solving the various general and lieutenant problem. Is there very famous mathematical problem? Is there a lieutenant general problem? So that if you want, whenever you have a free time, you please go through that Byzantine fault tolerance with the general and the lieutenant problem. Certain different applications are there, defense applications are there. So how you can dependability fault tolerance are there with the BFT algorithm is there. So certain consensus algorithm like proof of work, proof of stake, delegated proof of stake, and proof of work, and we have the practical Byzantine fault tolerance. So these are some consensus algorithm which is part of the components of the blockchain algorithm. Just a minute. I need a feedback from you. Able to follow up the sessions. Please put it in the group. So I have, sir, very few minutes to conclude the session. We started around 10:10. I'll be completing by 10:40. So that is 1 hour 30 minutes was the scheduled time. So if anybody anything is there, please raise your hand or unmute yourself and speak to me so that I can clear your doubts or anything. Okay. If anything is not there, I will continue. So so there are various consensus components are there, proof of work and proof of stake. So here, miner means not the physical mining concepts. This is a cryptographically you have to claim the ownership of the transactions. That is called as the proof of work. Proof of stake means a person can mine the depending on the how many coins he can own and he can use it. What is the ownership of the things? It should not be more than 51%. So because the if it's go the more than 51%, the ownership for the whole ownership will go to the single party. So that is a concept called in every industry. A mutual agreement will happen between 51% stake and the 49% stake. Usually the main beneficiary will get the 51% ownership and other people will get the 49% ownership. So blockchain structure is that. So they have that not the client server architecture. They have the distributed, decentralized, autonomous system. Peer-to-peer architecture is there. So with a pseudonymous client bearing the key and pair of key. So pseudonymous private key or hybrid key or anything are there. So blockchain, I told you know, sorry, it is a data structure. It contains the blocks. The first zero block is called the genesis block, and followed by blocks are identified. The first block is called also zero, identified with the zero value, the number, and that is called the genesis block. It have a when block is created, the mentioning reference number of the previous block is zero, nonce is the value, and hash have the by default certain hash value will be there, and in as the blocks are created and we are connected, the every connectivity is there. If anybody wanted to tamper these values, so the hash values, so the block will be terminated and the transaction will be incompleted. So your when you see the a blockchain structure, it looks like that block data. So using any Linux command, read write permission, file access permission, all those things that can be done with those things. So these are have every column have the different representation is there. So you can connect with this blockchain transaction with things that you can take up the things. So in consensus components are there called types of blockchain. We have concept called three types of the things. One is the main blockchain, public blockchain, private blockchain, and consortium or federated blockchain. So main blockchain is called the Bitcoin, which is introduced by the blockchain to the world. Public blockchain means anyone can charge, anyone in charge can be participant or any participant. So anyone can participate, reading, writing, auditing of the things like similar to Bitcoin or any other cryptocurrency. Litecoin can be done. Private means it's as I told you within the organization, private property, individual or organization or institution. So they can incorporate those things such as the read write permission or selectively give access to read or permission or read write vice versa. That one you can use that. Same thing like a bank chain. So then consortium or federated blockchain is there something like a federated model or a hybrid model. So more than one in charge, a group of companies are representing with the individual and can come together and make the decision with the best benefit of the whole network. Within the organization, there are multiple units are there. So that can be done or make it a consortium or a federated blockchain. That is the things are there. So let us uh, come to the end of the session. If anybody have the concepts, please assume tell me that any other doubt in the thing. And we have the smart contract theories there. So smart contract is something like computer protocol designed in the digital to facilitate it, verify, enforce the negotiation or the performance of the contract. So that means a physical contract is being digitized, authorized by the a contraction execution program, that is self-executing programs, I authenticated by all the stakeholders who are in the blockchain and perform with a credible transaction without third party, and transaction are traceable and reversible, that is immutable. But you can trace out the thing how the transaction, for example, ownership, how it is started, and who is the ownership or present, that you can see that you can traceable the transaction. So this is how the transaction is there. So if it is a signed by a message sender, check the enough coins are there, any other transaction. So if SC is there, so this is a smarter contract theory and architecture is there. So then we have the concept called decentralized autonomous organization is there. So that is called the DAO. DApps is different, DAO is different. DApps is for the Ethereum based application. DA was also one of the blockchain application where that is decentralized autonomous systems are part of the system. So in the blockchain ecosystems are there. So smart contract, assume that one of the case study I'm taking, lottery without smart contract. So organizer will be there, they will pick up the winner, then they will call the escrow account. Escrow is a account means a mediator will take care of the responsibility of the transfer amount between the two parties. So that is called the escrow account. That is a temporarily be in the particular agency who are responsible to transfer the winning money to from the organizer to the payment provider. So that is the escrow concept called the escrow bank or escrow account. So then there will be an company's conditions terminologies has to be taken. The payments terms and condition with satisfied, that will be taken into that. But when you apply the same blockchain concept with a smart contract, so same lottery concepts can be having the everybody can view the things are there, participant will be there, organizations are there, the event scheduler or the payment agency, gateway agency are integrated so that everybody can have the actual information and who is the winner, what is the amount we got the things, and instantly every transaction happen parallelly. If the organization uh, uh, done with the winning price or declare the price, who is the owner and who is the beneficiary, everything can be done with the smart contract, the digital pay. So another concept of group wallet. So how the contract will be there, so that can be done. So at least if you out of the three people are participating, if one agree, if the two agree, so that is a two-third of the agreement that will be, you can validate the transaction. So that is called as the see. Whereas heritage validate, secure storage things can be done. These are some of the, and we have to follow the certain uh, structure architecture as been mentioned by the NIST. I already told it's an institute which give the standard for the transactions. So international standards are there. So as Eric ERC 20 is the system proposed by the Fabian Walgelsetter. Ethereum ERC blockchain implementation tokens are there, so that can be validated. There are other tokens are there. So ERC 721, ERC 725 identity standards are there. These are the some of the standards are being utilized of the thing. So that is the things. Um, I am completing my session introduction class. So shall I, organizer? Shall I end the session? If any participant are there, please put your doubts or any queries so that I can uh, end my session. If I'm ready to take up some questions or anything, so that I can validate. I mean, I can end the session. Organizers, please.
Thanks for this session, sir. We are ending up now.
Okay, madam. Madam, if any questions are there, you have to tell. Otherwise, I will end the session, madam.
Guys, if there are any queries, please respond.
Okay, madam.
Yes.
Thank you.
Yeah. Thank you, sir. Thank you so much.
Thank you, madam. You can stop.